Okay, let's have a look at this question. Looks easy enough, but very, very easy to make mistakes with this. Okay, so we've got to solve the following equation. So first things first, let's draw an Argand diagram and understand what the argument and modulus of the complex number 2 plus 2i is. So it looks something like that. That's 2, that's 2. So the modulus is going to be root 8, 2 squared plus 2 squared square rooted, which is the same as 2 root 2. And the argument is going to be tan theta equals 1, so it's going to be pi over 4. So remember, it's multiples of pi over 4 plus 2 plus multiples of 2 pi. So it's pi over 4 plus 2k pi, which is equal to pi over 4 plus 8k pi over 4, which is, if I factor out the pi, I get 8k plus 1 over 4 pi. So that's going to be my argument for any given value of k. So my complex number, I can rewrite it in polar form as modulus, which is 2 root 2. Now 2 root 2 is the same as 2 times 2 to the half, which is the same as 2 to the 3 over 2. So I'm going to write it like that. 2 to the power of 3 over 2 of cosine of 8k plus 1 over 4 pi plus I sine of 8k plus 1 over 4 pi. Now I'm going to raise left and right hand side to the power of a third. So on the left hand side I get z. On the right hand side, using demoivre's theorem, 2 to the power of 3 over 2 to the power of a third is equal to 2 to the power of a half. So it's root 2. Okay. We're going to get then, we need to multiply the argument by 1/3. So it's going to be 8k plus 1 over 12 pi plus I sine of 8k plus 1 over 12 pi. Okay, so now all we need to do is find the roots by subbing in values of k. So let's first of all do it where k is equal to 0. We're going to get root 2 of cosine of pi over 12 plus I sine of pi over 12. Now, these are not standard ones. You're going to require your calculator for this. And you can just write it to 3 significant figures. It turns out to be 1.37 plus 0.367i. Okay, just using your calculator. Z2 will be the case where k is equal to 1. So we're going to get 9 over 12 becomes cosine of 3 pi over 4 plus I sine of 3 pi over 4. Now, don't need a calculator for this one, although I suggest this would have been a calculator question, so you could just use it just to be absolutely safe. But cosine of 3 pi over 4 is negative 1 over root 2. And I sine 3 pi, sine of 3 pi over 4 is positive 1 over root 2, so that's 1 over root 2i. That will simplify down to negative 1 plus I. Z3 is the case where k equals 2. So root 2 becomes cosine of 17 pi over 12 plus I sine of 17 pi over 12. Again, you're going to need to use a calculator for that. Turns out to be minus 0.367 minus 1.367i. So there are my 3 solutions. Now I'm going to display them on an Argand diagram so that I know I've done it right. Because watch what happens when I do that. Okay, let's do the easy one first. Minus 1 plus I. That's somewhere like that. Okay. 1.37 plus 0.367i. Well, it's maybe something like about here. And finally, minus 0.367 minus 1.367i would maybe somewhere like here. Okay? And what you can learn from that is that, you know, each of these angles would be the same. So it's equally spaced around, if you did it accurately, it would be equally spaced around the Argand diagram. And that's how you know you've done it correctly. The roots, the complex roots of any polynomial will be equally spaced around the Argand diagram. Okay, hope that makes sense.